Okay, so continuing the sample test. Now we're going to go ahead and simplify this. This is 27, so I'm going to take the prime factors of this. So knowing that this is a 3 and a single 3, and this 12 can be prime factored by doing 2, 6, and 2, and 4. Sorry, 3, my mistake. This 27 and the 12 can be done both in the same radical. This is a 3, a 9, a 3, and a 3. And the 12 is a 2, a 6, a 2, and a 3. So leaving me 2 3s, 2 2s. This has 2 2s and 2 3s. And so in the end it's 6. Is that. I've got 2 times 3 times root 3, or 6 root 3. And I've got minus 6 root 3. It's 3 times 2. Then minus, here's another couple of 3's as well. 3 times 3 times 2 is 9, 18. Okay, and now I combine these two for a negative 12 plus, well, actually, it's just a negative 12, because 6 root 3 minus a 6 root 3 becomes a 0. Now, we must, on this question, calculate the value of k so that f of x so that f of x has 1, 0. In order to have 1, 0, if a parabola has 1, 0, its discriminant is equal to 1. And so if I want this parabola to have 1, 0, I make its discriminant, its discriminant is equal to 0. Okay? And now the discriminant is a negative b, or is b squared minus 4ac. So I have a negative 4 squared minus 4 times k times k, because my c value is k, my b value is negative 4, my a value is k. Now I have to solve this equation for k. So if I square both sides, then I get 0 is equal to, forgot a square there, negative 4 squared minus 4k squared. And so it looks like I've got 0 is equal to 16 minus 4k squared. And now what I'll do is sort of move down onto this next piece of paper here. So now remember, I'm just still solving for k, so I've got 0 is equal to 16 minus 4k squared. If I subtract 16, divide by a negative 4. 16 divided by a negative 4 is k squared, and then if I square root both sides, I get plus or minus 2. Okay, so apparently a positive 2, when placed in here and here, will give me a 1, 0, or a negative 2, when placed in here and here, will give me exactly 1, 0 as well. Okay, next question. Number 5. Considering following function, find the x-intercepts, y-intercepts, vertex, axis of symmetry, maximum and minimum. Sketch the graph and make a domain and range. Okay, I'm going to find the x-intercept. So I'll set y equal to 0. I will subtract 5. I'll divide by a negative 3. Take the square root of both sides. I will add 2. These are my x-intercepts. Find my y-intercept. I will set x equal to 0. So if I set x equal to 0, now 0 minus 2 is a negative 2. Negative 2 squared is a positive 4. Negative 3 times a positive 4 is a negative 12. Negative 12 plus 5 is a negative 7. This is my y-intercept. My vertex. My vertex is 2, 5, because this is in vertex form. Get a calculator here and calculate the x-intercepts. I need to do 2 plus the square root of 5/3. .3, and then 2 minus the square root of 5/3, 0.79 or 0.71. Okay, and so now I've got a bunch of points. Vertex, x-intercept. X-intercept is 0.7, 0, 3.3, 0, 0, 7 is the y-intercept. Now I make a graph. One, 2, 3, 4, 5, 6, 7. is my y-intercept. 1, 2, 3.7, and a little bit past 3 are my two x-intercepts. And then I've got a 2, 5 vertex. And so my parabola kind of looks something along these lines here. Alright? It looks like my range is y is less than or equal to 5. My domain, x is a real number. My axis is x equals 2, and my maximum is y equals 5. Okay. Continuing with the next question. Now I've got one in factored form, the same thing. Consider f of x is equal to, 2x minus 3, x plus 7. State the direction of opening, x-intercepts, y-intercepts, vertex, axis of symmetry, maximum, sketches, and blah, blah, blah. All that stuff, right? So, in factored form, we can find the x-intercepts by setting y equal to 0. Okay. If I divide by 2, I get 0 is equal to x minus 3, x plus 7, product of. Then I've got the zero product problem, so my x-intercepts are positive 3 and negative 7. Y-intercept. Remember, to find the y-intercept, I evaluate f of 0. And so it's 2, 0 minus 3, 0 plus 7. F of 0 is 2 times the negative 3 plus 7, negative 41. Now the vertex. To find the vertex, I'm going to have to put it in factored form. Standard form. Standard form is going to be 2x minus 3 I just wrote f of x right there times x plus 7. F of x is equal to a 2x squared minus 3x plus 14x minus 21. F of x is equal to 2x squared plus 11x minus 21. This is in standard form. My a is 2, my b is 11, my c is a negative 21. Now, to find the vertex, it's a negative b over 2a, comma, f of negative b over 2a. So it's a negative 11 over 2 times 2, or negative 11 times 4, or